All right, today we're in section 15.1, finding square roots. More than likely, finding a square root is not an unfamiliar concept to you. You have done some level of this in the past, and we're going to take that knowledge and we're going to build on it today and really just kind of explore this concept of square roots. Okay, well, the first thing we need to know are just some of these bullet points that are right there in your notes. That squaring a number and finding the square root are inverse operations. What does it mean for something to be inverse? Okay, that is opposite. So the inverse of negative 10 would be positive 10, and those values cancel out. So what we see with inverse operations is that they actually can cancel each other out, and that's really important later in the lesson, okay? But for now, I need you to understand 2 squared equals 4, and the square root of 4 equals 2. You see how they kind of go hand in hand, okay? So a perfect square that has a factor that can be multiplied by itself to equal that number, that's what a perfect square means, okay? So you are going to have to memorize your perfect squares. Do you hear me? You have to memorize them. So what is a perfect square? It has a factor that can be multiplied by itself to equal that number. For example, 1 times 1 is? 1. So 1 is a perfect square. 2 times 2 is? 4. So 4 is a perfect square. 3 times 3 is? 9. So 9 is a perfect square. You need to start writing these perfect squares down. We're going to go out to 15, okay? So 15 squared, all right? Okay, 4 times 4 is? 16. Anybody know what the next one is? 5 times 5 is 25. 36, that's my 6's. 49's my 7. 7 times 7, 64. 81. 100. Okay, 11 times 11 is 121. 12 times 12 is 144. 13, times 13 is 169. 14 times 14. 196. Guys, do you see how these two are related? 69 and 96. That's an easy way to remember. And then 15 times 15, 225. These are your first 15 perfect squares. All right, and what is the range of these numbers? From 1 to what? 225. There are only 15 numbers that are actually perfect squares. Does that mean that it's a pretty common thing to be a perfect square? No. Most numbers do not have an even perfect square. We're going to talk more later in the chapter about what that means, about it being rational or irrational. But perfect squares are not very common. What does it mean again to be a perfect square? It has an even square root or a whole square root, okay? Each one of these numbers has a factor that can be multiplied by itself. All right, now we need to talk about the radical, okay? That thing I just circled right there, that's what we call a radical. You're going to hear me say that a lot this chapter, so you might want to write that off to the side and draw an arrow to it. That is a radical. And it is positive. That's so important. Unless there is a different sign in front of it. Okay? It's going to be positive. Unless there is a negative or a positive negative, which we'll talk about in just a minute. Okay, so these concepts are really important for us to understand what's going on in section 15.1. All right, so the first part of example 1 is real simple, okay? Actually, we just wrote all of these numbers down as perfect squares. And conveniently for this section, especially in 15.1, any number that you're asked to find the square root of will be an even square root. You don't have to worry about it being a decimal or anything like that. All right, so go ahead and write down the answers for all of these. What is the square root of each one of these numbers? Go ahead and write that down. All right, so what is the square root of 49? 7. What about 100? 10. What about 121? 11. And 36? 6. Okay, so again, these are factors that can be multiplied by themselves to equal the original number. But look at these numbers. What am I doing here?
Making an inverse.
The inverse. What's negative 7 times negative 7?
Negative 49.
49. What's negative 10 times negative 10? 100. What about negative 11 times negative 11? So what is true, and I don't know if you caught this in the title of the example, but it says to find the square roots, plural, of the number. Because when it's just the number, it actually has a positive square root and a negative square root. Because it is also true that negative 7 times negative 7 is positive 49. All right, you see that? So the negative square root is true also. But you're not going to write it like this. You're going to write it like this. You can just cross it out. You don't have to erase it. It's a good reminder for you. We're going to write it with what we call the positive negative symbol. So instead of writing two answers, we're just simply going to write the number with a positive negative symbol in front of it. And this is how I want you to write the answer. So if you write it with the two numbers, technically that's correct, but this is how I want you to write it. All right, with the positive negative symbol in front of it. That means that my acceptable answer is both positive and negative. Okay, so we're just going to clear that up right there. Okay, what do you notice that's different about example 2 compared to example 1? What do you notice that's different, Kennedy? Okay, and she used the correct term too. She said a radical. So the square root symbol, what did I say at the beginning of the lesson about the radical? It's positive. So that now means that I am defining the sign of my answer from the original problem. So on the first one, I see the square root of 25. So that's just going to be 5. If you put a positive negative there, that's actually wrong. So the sign of your answer is very important. Okay? So now let's go down to the negative square root of 49. Well, what is the square root of 49? 7. And because the negative is out in front, it is defining your answer as negative. So my answer is negative 7. So what happens if you just put 7? Is that correct?
Yes.
No. Okay. So what do you think about the top right one? So what do you think is going to go in your answer? Positive, negative. Give you a wild guess on the last one. Negative 9. Okay? So when the radical is a part of the original problem, it will define your answer as either positive or negative. Okay? Any questions on that? All right, example 3. Okay, so here in example 3, you see what? What do you see here, guys? You see fractions, right? And you're like, oh, that looks really complicated. Well, here's what I need you to understand, okay? I need you to look at the actual fraction, inside the fraction, and realize that each one of these numbers are actually what? Starts with a P. They're perfect squares, okay? But what if maybe the numerator was not a perfect square, or the denominator was not a perfect square? And you're going to see that in Algebra 1 especially, and beyond, is this idea of, all right, and here's where it kind of sounds more complicated, but it's the idea of simplifying a radical, okay? And that's kind of what we're starting to do. We're trying to simplify the terms that are underneath the radical. Well, it can be split. numerator and denominator, just in case maybe I can't take the square root of my numerator or denominator. Okay, I can split it and then I can take the square root of either one. Well, it just so happens in this case, I can take the square root of both, right? What's the square root of 9? 3. What's the square root of 16?
4.
And that's my answer. Can't be reduced. It's done. And then just make sure that your answer carries over the sign from the original problem. So if it was negative, make it negative. If it was positive, negative, make it positive, negative. All right, go ahead and finish the rest of this section. All right, so let's do the next one. What's the square root of 36? 6 over 9, and can that be reduced? 2/3. Positive, negative. Okay. All right, what about the square root of 1? 1. What about the square root of 100? Negative 1/10. What about square root of 4? 2/5. Okay. And notice, guys, on the other 3 problems, I did not show the numerator and denominator being split. I did not show the second step. That's okay. You don't have to show the second step. All right, because again, we're not gonna. I'm not gonna say we're not using calculators at all in this chapter, but they are going to be used to a very minimal degree. Okay, so anyway, and these are the perfect squares that we're gonna have memorized. So I would expect you to have it memorized and not really have to show that work. All right, moving on to example 4. And example 4 is where we are going to leave off for today. Okay, example 4 says to evaluate the expression that is involving square roots, okay? So the first thing I need you to understand is what operation is actually happening between the number and the radical, between the 5 and the square root sign. Do you see a plus sign there?
Yes.
Do you see a minus sign? No. So what do you think is happening? Multiplication. All right, what is the square root of 36?
6.
So does that mean it's 56? No. There is an operation, and that is multiplication. Okay, this means 5 times 6 plus 7. What is 5 times 6?
30.
Plus 7?
37.
37. All right, so now I want you to do these two over on the right-hand side. We're going to come back to the fractions. Okay, do you guys remember what I talked about with inverse operations?
Yes.
You can actually solve this without doing any math at all. No math. If you can recognize that if I take the square root of a number and then square that very same number, those operations undo themselves. And the answer is just the number.
Yes.
Okay? All right, let me say that one more time. If you take the square root of a number and then turn around and square that same number, your answer is just going to be the number that was underneath the radical. Okay? So your answer is 81. Let's say for a minute that you forget that. Okay, you can actually solve this. What is the square root of 81? 9. And then what is 9 squared? 81. And you're right back where you started. Okay, it's like running around in a circle and coming right back. Okay, so remember the square root and the square are inverse operations. If both of those operations are happening to the same number, they undo themselves. They cancel out. Okay? All right, look at the next one. Here's the biggest question. Do I need to subtract 12 minus 3 before I multiply?
Yes.
No. The multiplication must happen first. Okay, hold your question one sec, Sarah. Okay, I'll get it in just a sec. All right, I must simplify the multiplication before I subtract. All right, that's the number one mistake that I see. What is 3 times 5? 15. And then 12 minus 15 is negative 3. Now let's look at the fraction, the square roots of the fraction. 1/4. Uh-oh. I can't take the square root of either one of these numbers. But, okay, so it really is going to be a case-by-case basis. Sometimes, if you simplify the fraction, you can no longer take the square root. Sometimes, if you don't simplify the fraction, you actually can't really simplify the square root, okay? In this case, the second option is true. I can't do the square root of 18. But if I do 18 divided by 2, what is that?
9.
And what is the square root of 9? 3. Okay? Now, 1/4 plus 3, okay, is 3 1/4. Okay? But you also need to understand that you could turn 3 into a fraction that can be added to 1/4. What is a fraction that would have 4 as the denominator? Yes, and still equal 3. 12 over 4. And we're showing this, guys, you're literally going to end up at the same answer. Well, we're showing this to show you that whole concept of common denominators. Okay? So that's important. All right, one more slide. One more slide. Whew, deep breath. I know we've covered a lot today. Okay, I want you to do these two on your own. Go ahead and do these two on your own. Give you about 2 minutes and then we'll check them. Guys, what's 28 divided by 7? 4, what's the square root of 4?
2.
What's 2 plus 2.4? 4.4, okay? Now on the second one, all right? Did anybody catch that these two are inverse operations?
Yes.
All right, so 15 minus 4 is 11. 15 minus 4 is 11. And again, if you did the square root of 4 to get 2, 2 squared is 4. Still the same thing. All right, this is the end of part 1. Okay, we're going to do a classwork assignment on this tomorrow, but there is no homework. And I will post that in Remind and on the portal this afternoon.